Assalamualaikum and hello. This is our video for group assignment basic material 2018-2019 and the product we choose is gold jewelry. Before I move on, I will introduce the members of the group. Mohamad Iqbal bin Karim, Imran Baqthiar bin Zulkifli, Mohamad Faiz bin Badrul Hisyam, Najmi bin Ismail, Mohamad Hafiz Fahmi bin Ahmad Shukri. What is gold jewelry? It is one of the major market in the world. It is used by people for wedding and special occasion. It is a massive attraction by mankind. It does not cause skin irritation and it has been used as currency up until 1961. So the material that we choose from the gold jewelry is gold alloy. Pure gold is always mixed with alloy to create carat gold. All carat gold jewelry use alloys to help enhance the pure gold. Alloy provide hardness and durability as well as color variation in gold. Alloy can impact other factors such as weight, strength, shine, and in certain cases, factors such as the hypoallergenic nature of gold. This is the schematic diagram of gold jewelry which were designed by our group using SolidWorks. This is the cross-section of gold jewelry. Now I will move on to the microstructure of gold alloy. Gold, as other ductile metallic element, is characterized by a face-centered cubic crystal (FCC) structure in its metallic form. It is one of the anomalies that distinguish gold from other FCC metal is the possibility to easily reconstruct all the three high symmetry plane, probably due to relativistic effects. The crystal structure of gold, with a multiplicity of closed packet plane on which slip can occur, makes it more ductile in comparison with others. Gold forms other element a wide range of intermetallic compound. For example, gold aluminum, gold indium have a well-defined color due to their reflectance minimum in the visible part of the spectrum. This low energy behavior is caused by the presence of several bands of conduction electrons in agreement with Fermi surface studies and a developed secondary band H in the visible.
So moving on to development of microstructure. Grain refinement. The grain refinement is a mechanism that provides several advantages to the material. Nowadays, this form of control is used by processing and microalloying additions to optimize the gold alloy's properties in different application fields. Trying to consider all the advantages and benefits related to the reduction of the grain size, it is possible to draw up a list. Increase of strength, increase of malleability and ductility, increase of the corrosion resistance. And moving on, strength and ductility, the movement of dislocations, lattice defects that causes the sliding of crystal planes of the structure characterizes the deformation of the metals. The movement of these defects become more difficult with the increase of number of distortions or various obstacles presented in the crystal structure. This leads to a reduction in malleability of the gold alloys and an increase in hardness. The main strengthening mechanisms valid for gold alloys are precipitation hardening, mechanism of precipitation with the decrease of the temperature of dispersed particles by specific heat treatments. Next one, solid solution hardening, The atoms of the alloying elements can modify the structure of the crystal lattice. And finally, disorder order solid transformation hardening. With the lowering of temperatures, specific sites of the crystal lattice are occupied by different atoms, creating an ordered solid solutions. Recrystallization during annealing and after cold working. During deformation processes such as swagging, hammering, sheet rolling, or wire drawing, the microstructure of metal alloys is heavily deformed with a reduction of the ductility to lower levels. The material becomes progressively harder and more difficult to work as lattice defects increase in number. To restore the initial malleability of the gold alloys, an annealing process is required in order to soften the material and allow further deformation steps. The characteristics of the new structure resulted from the recrystallization depend on the parameters of the heating treatment and on the previous deformation performed. The value of deformation is very important to define the capability to recrystallize during annealing treatment. If the deformation produced is too small, then the energy stored in the form of lattice defects may be insufficient to promote complete recrystallization of the metal. Increase the hardness, increase its melting point, increase its modulus of elasticity, increase its strength, finally many variety of colors. Height, hardness, and strength. The silver atom is slightly larger than that of gold. Alloying gold with silver gives a moderate improvement in strength and hardness. Other than that, the copper atom is significantly smaller than that of gold. Hence, it has a greater effect on strengthening gold than silver, as it distorts the gold crystal lattice more. By that, reducing caratage from 24 carats to 22 carats down to 18 carats, gold results in stronger and harder alloys. Variety in colors. Colored gold alloys are just as real as their golden colored counterparts. Pure gold is generally too soft to be used for jewelry, so other metals are nearly always added to it. This is regardless on the matter of which color of gold is being prepped for jewelry making. You can see this is a table of color of golds that exist and its compositions. Thank you and good night.